Our next set of identities that we're going to work with are the half-angle identities. And these do exactly what they sound like. They're going to take an angle of rotation, cut it in half, and give us the exact values for the sine, cos, and tan for that new angle, for that half angle. So pause the video, take a minute, and record these three identities into your notes. And the deal here is the same with these as was with the double angle identities. You don't have to memorize these. They'll be given to you on all assessments. You just got to know when to use them and how to use them. So let's say I know the cos of an angle is 1/8. Now that's positive 1/8, so that means our angle could either be in quadrant 1 or quadrant 4. So let's go with theta being between 270 and 360, or in other words, quadrant 4. Now the nice thing here with these three identities for the half angles is notice all of them involve cos. So if I am given cos in the problem as we are here, I don't need to draw my triangle and figure out the sin and the tan, and all the different sides of the triangle. I can just use cos as 1/8. So let's figure out sin of half of theta given this information. So here's our identity. The first thing that I'll do here is deal with this plus or minus in front of the square root. We're actually going to have to choose whether it is positive or negative. Now how we do that is we think back to our original angle between 270 and 360. If I were to cut this angle in half, that means my half angle is going to be somewhere between half of 270 and one half of 360, which is 180. So my half angle would actually fall in quadrant 2 between 135 and 180. So in quadrant 2, is sin positive or negative? It is positive. So my answer to sin 1/2 is going to be positive. And now I'm going to plug in that cos value. Cos of theta is 1/8. So no more word in there now. Now it's just all numbers that we can simplify down. So it's going to be positive. When I do 1 minus 1/8, that's actually going to be 8/8 minus 1/8 all over 2, which will turn into 7/8 all over 2. And then if I want to change that to 7/8 times 1 over 2, instead of dividing by 2, that'll change this into positive radical 7/16. And lastly, let's split this fraction up into two square roots. Square root of 7 over square root of 16, which is really going to be positive square root of 7 all over 4. Let's take the same information now and find cos of half of our angle. So here is our identity for cos. Very similar to sine of half angle, but it's a 1 plus cos underneath the square root. So now again, let's decide on the positive or negative in the front. If our half angle is still between 135 and 180 in quadrant 2, that means cos is negative in quadrant 2, so we're going to pick the negative sign for cos half angle. And now I will plug in 1/8 for cos theta. And again, this will now be 1 plus 1/8, or 8/8 plus 1/8, which will be 9/8 all over 2. And then, if I want to change that division to multiplication, it'll be 9/8 times 1 over 2, which will be negative square root of 9/16. And then split that fraction up into 2 square roots. And this works out nicely that both of those are perfect squares. We're going to get negative 3/4 for the value of cos half theta. And lastly, let's do tan of half of our angle. So again, our half angle would land in quadrant 2, where tan is negative. So I'm going to pick the negative sign, get rid of the positive, and now plug in 1/8 in for cos. So we're going to have 1 minus 1/8 over 1 plus 1/8. So changing those 1's into 8/8, that'll be 7/8 over 9/8. And now notice this complex fraction, the 8's, we have common denominators, so we can forget about those. So we're going to get negative square root of 7/9. Split that fraction up into 2 separate square roots. We're going to get negative radical 7, and the square root of 9 is 3. And there's the value for tan of half of our angle.